Hello dear students, so now we would move ahead in this chapter number 2 of class 10 science, that is acids, bases and salts. So today we would be classifying the bases on different bases. Likewise, we have classified the acids also on different bases like weak acid, strong acid, etc. So today in this lecture we are going to classify the bases now on different bases. So let's say on the basis of strength we have two types of bases. On the basis of strength we have two types of bases, strong base and the weak base. Okay, so on the basis of strength, if you are classifying the bases on the basis of their strength, so we would have two types of bases. Some would be the strong one and some weak one. Okay, strong base and weak base. Okay, now what are the strong base and what are the weak base? Means strong base are those which undergo complete ionization in their aqueous solution. Okay, the bases or alkalis which undergo, alkali same it is. Okay, the bases or alkalis which undergo complete ionization in their aqueous solution are termed as the strong base, and which do not undergo complete ionization, means which undergo partial ionization, we would call such bases as the weak base. Are you getting this? For example, we have a base here, that is NaOH. So in its aqueous solution, NaOH would undergo complete ionization, means it would be separated into all the positive and the negative ions, Na positive and OH negative ions. So this is how ionization will take place in case of the NaOH, that is sodium hydroxide. So here we have the complete ionization, means it would be separated into all positive and negative ions. Nothing would left there now. Are you getting this? So NaOH is a strong base. Why? Because in its aqueous solution it is completely ionizing, okay, and giving Na positive and OH negative ions. But if you take the example of LiOH, that is lithium hydroxide, LiOH, it would not undergo complete ionization, rather it will undergo partial ionization. So it would be separated into Li positive ion and OH negative ions, lithium hydroxide, lithium positive one ion and OH negative one ions. Okay, so this ionization is not the complete ionization here. Some positive and negative ions would not be separated, some are being separated. Are you getting this or not? Yes. So LiOH means lithium hydroxide would not undergo complete ionization, rather it would undergo partial ionization. So we would call LiOH as the weak base. We would call this LiOH as the weak base. Okay, because it is undergoing the partial ionization. Are you getting this? Very good. Now, how to find whether a given acid is a weak base? Sorry, how to find out whether a given base is a weak base or a strong base? Do we have any criteria for that? Yes, we have. You must have read the periodic table. If not, we would read about the periodic table later in the chapters ahead. Okay, a separate chapter is there for the periodic elements there for you in the chemistry there. So let me tell you, there in the periodic table we have different groups. All the elements have been divided into different groups. Okay, likewise in the first group we have the elements like, this is the first group, we have the elements like hydrogen. Okay, and then we have the this lithium, then we have sodium. Okay, then we have potassium. Okay, then we have their rubidium, then we have their cesium, then we have their francium. So these are the elements of the first group: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So these are the elements of the first group there. Are you getting it or not? These are the elements of the first group. Similarly, we have the second group also. In the second group, we have beryllium, we have their magnesium, then we have their calcium, then we have their strontium. Okay, then we have their barium, Ba, that is. Okay, then we have there the radium, sorry. Okay, so these are the elements of the second group. So when we go down the group, so the basicity increases. It means the bases formed by the elements down the group would be the stronger bases. Remember this, the bases formed by the elements, those who are down the group, would be the strong base. Okay, like the base formed by francium would be the strongest one. Cesium, strong base. Rubidium would form the strong base. Potassium also would form a strong base. Sodium also, sodium hydroxide here. Sodium is forming sodium hydroxide. So again sodium would again it would form the strong base. Are you getting this? But lithium is upper one there, so it would not form the strong base. So the elements which are upside would not form the strong base, rather they would form the weak base. So the basicity increases. Okay, the basicity increases down the group. Are you getting not? Similarly, in the second group also the basicity would increase down the group. As you go down the group, the bases formed by the elements would be the stronger one. Okay, like magnesium, like calcium, the base formed by the calcium would be stronger than the base formed by the magnesium, and the base formed by magnesium would be stronger than base formed by the beryllium. Are you getting it or not? So if you are going down the group, the bases formed by these elements would be stronger now, stronger to the previous one. Are you getting it or not? Very good. Means the bases formed by the elements which are down the group would be the stronger to the previous one. Okay, like the base formed by potassium hydroxide, that is KOH. Base formed by potassium is what? KOH. So it would be stronger than the base formed by the sodium, that is NaOH. So if you go down the group, the basicity increases. Okay, so sodium hydroxide, potassium hydroxide, these are termed as the strong base because they undergo complete ionization in their aqueous solution. Means it would be separated into all the positive and the negative ions. This is ionization is taking place here. Okay, but in case of the lithium, as it is the uppermost element here. Okay, so it would not undergo complete ionization, so it would be termed, the base formed by the lithium would be the weak base. Similarly, the base formed by the beryllium also would be the weak base, but the base formed by the calcium would be like calcium hydroxide, CaOH whole twice, calcium hydroxide. So it would form a which one base there? It would form a which one base? Strong base, and it would be stronger than the magnesium one. Okay, so this is how we would find out whether a given base is a strong base or a weak base. Are you getting it or not? So you just note it down for your brief knowledge. Then I would be writing all about the strong base and the weak base. Okay, just note it down. So this is what you have to write in your notebook. Okay, so on the basis of strength, we have two types of bases: strong base and the weak base. The alkalis or bases, same it is. Okay, alkalis or bases which undergo the complete ionization in aqueous solution are strong alkalis or strong bases. For example, NaOH, sodium hydroxide, CaOH whole twice means calcium hydroxide. Why it is 2 here? Because the valency of calcium is 2. Are you getting this? Valency of calcium is 2, that is why it is 2 there. Valency of sodium is 1, that is why nothing is there. Are you getting it? Yes. So these are termed as the strong base. Similarly, the weak base, the alkalis or bases which undergo only partial ionization in their aqueous solution are known as weak base. LiOH, that is lithium hydroxide. BeOH whole twice means beryllium hydroxide. Why 2 here? Because the valency of beryllium is 2. So now you would be knowing now the elements which are there in the first group. There I have written only one time there. NaOH, LiOH, these are the elements of the first group, because the elements which are there in the first group all have the valency that is 1 there. The elements of the second group all have the valency 2. So the bases formed by the elements of the second group, you would write here 2 in all there. Are you getting this? Like calcium hydroxide, beryllium hydroxide, magnesium hydroxide. Are you getting this? So this is how we would classify the bases, or the bases on the basis of strength. Are you getting this? Just note it down. Then after we would be we would have another classification for the bases. Okay, just note it down. Now we have another classification of the bases, that is on the basis of acidity. Likewise we have done in case of the acids also. We have classified the acids also on the basis of basicity, like monobasic acids, dibasic acids, tribasic acids. Are you getting it or not? So similarly, here we would classify the bases on the basis of acidity. So on the basis of acidity, we have three types of bases. On the basis of acidity, we have three types of bases. First one, monoacidic bases, then diacidic bases, then we have the triacidic bases. Monoacidic bases means the base or alkali on complete ionization produce one hydroxyl ion, means one OH negative ion in the solution. Okay, means the base after complete ionization, if it is producing one hydroxyl ion in the solution, you would call such base as the monoacidic base. Like we have NaOH. So after the complete ionization, this is giving what? Na positive and OH negative ion. So only one hydroxyl ion it would produce. This NaOH would produce only one hydroxyl ion here. So you would call NaOH as the monoacidic bases. Mono means one. Are you getting? And if it is producing two hydroxyl ion, then you would call it as a diacidic bases. For example, we have calcium hydroxide, CaOH whole twice. So it would produce two hydroxyl ion from here. Are you getting it or not? Yes. So calcium hydroxide would produce two hydroxyl ion in its aqueous solution. So therefore, we would call calcium hydroxide as the diacidic bases. Are you getting it or not? Very good. So means the bases which after the complete ionization produce two hydroxyl ion are known as the diacidic bases. Similarly, the bases which after complete ionization produce three hydroxyl ions. Okay, like in case of aluminium hydroxide, AlOH whole thrice. So it would produce three hydroxyl ion there. Okay, so if it is producing three hydroxyl ion, so then it is triacidic base. So what are the triacidic bases? Means the bases which after complete ionization produce three hydroxyl ion in their solution would be termed as the triacidic bases. Hope you are getting this. Okay, now let me write this all one by one that you have to write in your notebook. Are you getting it? Very good. So this is what you have to write in your notebook. On the basis of acidity, we can classify the bases in three ways: monoacidic bases, diacidic bases, and triacidic bases. Monoacidic bases means the bases or alkalis on complete ionization produce one hydroxyl ion, means one OH negative ion. We would call such bases as the monoacidic bases. For example, NaOH, LiOH, etc. Means all are giving one hydroxyl ion, means all have the valency one there. So you can say the elements of the first group. We have already written the elements of the first group. Yes or not? Hydrogen, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements of the first group we have already written. So all the elements, the bases produced by all the elements there would be the monoacidic bases. Getting it or not? So similarly, diacidic bases means the bases on complete ionization produce two hydroxyl ion. So which would produce two hydroxyl ion? Means the elements of the second group that we have already discussed. Getting it or not? That we have already discussed the elements of the second group. Just now I have told you. What are the elements there? Elements were beryllium, magnesium, okay, calcium, strontium, then you have barium, then you have radium. So these are the elements of the second group you have already done. So the bases formed by these elements would be the diacidic bases, because they would produce two hydroxyl ion in the aqueous solution. Okay, so similarly, triacidic bases means the bases on complete ionization produce three hydroxyl ions. So which would produce the three ion? That means the elements, you can say, of the third group. What are the elements of the third group? Elements of the third group are B, Al, gallium, indium, then you have thallium. These are the elements of the third group. So the bases formed by all these elements would be the triacidic bases, like boron hydroxide, like aluminium hydroxide. Sorry, this would be aluminium hydroxide. So the bases formed by these elements would be the triacidic bases, because they would give 3 hydroxyl ions in their aqueous solution. Are you getting it or not? So that is all for today. Would be discussing about some more classification of the bases in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.